The last example for this section, find the greatest and the least values. So we're talking about the y values, the smallest y value, the largest y value of y equals x cubed, subtract 6x squared plus 5 on this interval, -2 to 5, and including -2 and 5. So the greatest and least values. That means we're looking for local mins and maxes. But because we're looking at this interval, we also need to check those endpoints in case they are smaller or bigger than our local mins or maxes. X equals -2 and x equals 5. So again, first thing we want to look at is find the derivative. The derivative function. 3x squared subtract 12x. Then we want to draw a sign diagram of it. Okay, in order to do that, we need our critical values. Critical values of this function are, we can see when it's factored. So when this function equals 0, and that's going to occur when x is 0 or when x is 4. So our sign diagram will have these 2 points on it, 0, 4. Okay, we can test some values in each of these intervals, or we can look at what the function is. It's a quadratic, so we can know that it's positive, negative, positive, because it opens up. Determine the actual points on f of x. So f of 0 is 0 cubed, subtract 6 times 0 squared plus 5, which is 5. So we have this point 0, 5. Now we need to look at classifying it. If we look just at this part of our sign diagram about the 0, we can see that it is increasing and then decreasing, which refers to a local maximum. Similarly, let's find the corresponding y value that goes with 4. 4 cubed, subtract 6 times 4 squared plus 5. We do that math out, it equals -27. So we have this point, 4, -27. Take a look at our sign diagram just in that localized area. So around the 4, and we are decreasing and then increasing, referring to a local minimum. Now remember, we're looking at this interval. So we also have to check those endpoints. So the last step would be check the endpoints. In case one of those endpoints, or both of them, are higher or lower than the points of our local min and max. So one endpoint was -2, so f of -2 equals -2 cubed, subtract 6 times 2 squared plus 5, and that works out to be -27. Okay, so this is also another maximum point in this interval, highest point in this interval. So we need to keep this in mind. Check our 5 value, 5 cubed, subtract 6 times 5 squared plus 5. That equals -20. That's not of interest to us because it's not a lowest or a highest point. Okay, so to answer our question, find the greatest and least values of this function between that interval. We say that the greatest value is 5 and occurs at x equals 0. The least value is negative 27 and occurs at x equals 4 and also x equals negative 2. There we have it.